Now let us explore the Sine Law. So if we have a triangle A, B, C, okay, and it's not a right triangle, but we still need to find some information. So imagine we have this angle A, and we have A is equal to 5, and we don't have that B, and we have B is 7, and we need to find other angles and the other length. So to do that, you apply the Sine Law. The Sine Law is very easy to memorize. It's just sine of A, of the angle A over A is equal to the sine of B over the opposite length to that angle is equal to sine C over the length of C. Same thing. So you have A, for example, you are given A is 43 degrees, and you have the length of this leg, which is 5, and you don't know B, but still you have the length of this leg B. So we can do that by applying this Sine Law. So the sine of 43 degrees over 5, which is A, is equal to the sine of B over the length of B, which is 7. And from here I can isolate for sine B. So sine B is equal to 7 times sine of 43 degrees divided by 5. And here you can just plug this in your calculator and plug this in your calculator, and you will get the exact information of sine B. And when you get the sine B, you can do sine minus 1. For example, suppose you find the sine of B is 0.435. You put in your calculator sine minus 1 of 0.435, and it will give you the angle B, which is, for example, 57 degrees. Okay, in the same way you can also do like this. You can also do the opposite. You can also do the A over sine of A is equal to B over sine B, and from there you can also isolate for sine B. So let's us talk about the Sine Law in this illustration, using this illustration. The objective of this demonstration is just to show you how actually this is accurate. So we have a triangle ABC here, and we have different angles here, and we can see that if we change the angle, the red A over sine A is equal to 23.682, and same thing B over sine of B is exactly the same number. And if I change it again and I change the angle, the measurement will change of the sides, and the angle will always change, also change, but the ratio of a side over the sine of the law is always this is always the same. So to better understand the ambiguous cases in a triangle, so let's us start with one angle of 30 degree. Okay, angle A is 30 degree and B is 10. Okay, and my A is smaller than H, which is 5, and less than B, which is 10. I am not able to form any triangle. So you can see, even if I swing my A, I cannot form any triangle. When my A is equal to H, which is 5, so my A is 5 and my H is 5, they are both of them equal but less than B, I am able to form one triangle, which is a right triangle, which is the yellow one. If I go more, swinging more my A, I will not be able to form any triangle. If my A is less than B, however bigger than H, as you can see, my A is 6.5, which is bigger than H, and less than B, which is 10, I can form two triangles. This is the first one, okay, and this is the second one. Okay, in this case I am able to form two triangles. And also the angles you will see the first triangle that I was able to form have one angle of 50 degree for B, 50.4 for B, and in the same time I can form another triangle which have one angle B of 130 degree. Okay, good.